Welcome to the After On podcast. I'm your host, Rob Reed, and this is a series of conversations with thinkers, founders, and scientists. Take a little time and stretch out, because these talks are unhurried and meant to bring you to a top percentile understanding of something important. So, whether you're into startups or ideas, a techie or a lit major, take your time, engage your mind, and you'll be glad you did it. Especially this week, when we'll be talking to British Astronomer Royal Martin Rees. And just to state the obvious, Astronomer Royal is such a cool title. And it's just one of an amazing list of positions and honors that Sir Martin has earned over his 5-decade career in astrophysics. If you're new to the show, welcome. It features in-depth conversations with world-class experts about their domains of knowledge. In each episode, I try to bring you, and myself, a serious grounding in something complex and important that we should all probably understand a bit better. If you enjoy this episode, please browse the show's archives at after-on.com or in your favorite podcasting app. There you'll find a bunch of fascinating conversations with some of the world's top people in robotics, synthetic biology, neuroscience, cryptocurrency, drones, augmented reality, and many other fields. Today's episode is a bit unusual in that it has a companion article, the first in an integrated series of 4 articles, which will appear on consecutive weeks throughout October. The series is called Privatizing the Apocalypse, and installment 1 has its own subtitle, which is The 50/50 Murder. That article should appear online at the very instant I post this podcast. At least that's what my editors and publishers at medium.com and I will attempt. The cheerful subject of this article series is existential risk, which is to say the potential for 21st century technologies to run amok or for them to be hijacked by deeply malevolent parties. In frighteningly plausible worst-case scenarios, this could quite literally lead to the annihilation of the human species. Yes, really. And my article series will discuss these risks in significant depth. As for today's podcast episode, it actually strongly complements that written series in that Martin Rees is quoted multiple times in today's article. His thinking also inspired several elements in the upcoming installments of the article. Now, I should stress that it's not necessary to read the articles in order to follow, enjoy, or understand this podcast episode, nor vice versa. They are fully standalone elements of thought and media, but they do complement each other rather nicely. A quick background about Medium.com. Most of you probably view it as a place where hundreds of thousands of people self-publish articles every week, and that is indeed quite accurate. But there's a new-ish side to the site as well, in that Medium now hires professional writers like me to create pieces that are available to their paying members. Now, the good news is non-members of the Medium site get access to 3 articles per month for free. And since it's the first day of the month, as I'm posting this hopefully won't present a barrier to any of you. You can find the first article of my series at medium.com/@RobReed. And yeah, you do need the @ symbol in there. I'm afraid it kind of complicates the URL. So it's medium.com/RobReed, and Reed is spelled R-E-I-D. My article may also be on Medium's front page for a while, and I'll, of course, link to it from the show notes associated with this episode on my website, which is after-on.com. A final note, Martin is my second astronomical guest in a row. In fact, he was the thesis advisor to my most recent guest, Priya Nararanjan of Yale. But if you're less interested in the heavens than some of the other topics we tackle on this show, fear not. About 90% of today's conversation with Martin is not about astrophysics. It's rather about what we need to do to survive this century. That said, Martin and I do hit a couple of really cool deep space topics. I couldn't help myself. Toward the start of the interview, we discussed the most violent events that have occurred in the universe since the Big Bang itself. And one of these things goes off with zero warning somewhere in the universe, the observable universe, once a day, roughly. It's crazy and fascinating stuff, and Martin's an expert in it. Then toward the end of the interview, we discuss a really eerie phenomenon, which are intensely strong radio wave sources, which have utterly mysterious origins.
And while this will sound sensationalistic, it's not at all out of the question that their source could be, wait for it, advanced extraterrestrial civilizations. Now, the astronomy community has come across mysterious celestial phenomena multiple times in the past, which have been suspected of being of alien origin, but have ended up with natural explanations, which are now well understood. The classic example of this is a phenomenon called pulsars, worth Googling if you're interested. But scientists have been puzzled by these mysterious radio bursts that Martin and I will discuss for about a decade now, whereas pulsars took about a year to more or less be figured out, and that was using 1960s technology. So today's radio bursts are pretty strange. Now, to be clear, Martin himself is by no means advocating that aliens are causing them, but as the years continue to tick by without an explanation, this mystery will feel increasingly strange. Last, I've got something really cool and special this week for people who back this show with monthly donations of $5 or more on Patreon. I will tell you about that after the interview. If you're not backing the show, I'm still delighted and honored that you're listening to it. But if you want it to survive, please spread the word about it. You can retweet the detailed descriptions that I post about every episode at Rob_Reed on Twitter. You can just tell people about the show. And the easiest thing of all, you can take about 15 seconds to rate the show on iTunes, which influences Apple's promotional algorithms. This is important because I really want to grow my audience to the point where I can bring on advertising in a quality way rather than a somewhat icky way, which I could have started doing a long, long time ago, because the audience here is not small, but it's not quite giant yet. And that requires a somewhat larger audience than I have now, high quality advertising. So please do spread the word if you want this show to last well into 2019. And with that, let's join Astronomer Royal, Martin Rees. First, thank you so much for inviting me to your office's beautiful and historic Trinity College here at Cambridge University. Now, Trinity has quite a history not only in producing, I think, a half dozen prime ministers or something incredible like that, but a lot of people of great note in your own field of physics, correct?
Well, I think it's more famous for its scientists. I mean, the best student we ever had was Isaac Newton.
Of course.
In the mid-17th century. It's been downhill ever since, but we've had some pretty famous names since then, and I hope the trend continues.
I hope it does. Well, Niels Bohr, correct? James Maxwell, am I correct in these?
Maxwell, certainly. Bohr was only a visitor. I'm not sure we can claim very much of him.
Oh, okay.
But J.J. Thomson of the electron and Rutherford and other great physicists and great physiologists as well.
And of course, Priya Natarajan, my guest from quite recently, was here for a period of time. So I'd first like to set a bit of context by talking about your personal background very briefly. You were born in the throes of World War II, and then you were educated at a school your parents began, correct?
That's right. After the end of World War II, my parents started a small private school in the country of Shropshire near the Welsh borders, and I went there till I was 13. I was then sent away to a conventional boarding school. From then, I came on to Cambridge University.
And you've been here off and on, but really more or less continuously in one way or another ever since, correct?
Well, I spent most of my career here in various capacities, but when I graduated, I had spells in various American universities, and also I was a professor at the University of Sussex, which is in the south of England.
Where were you in the US?
Well, when I got my PhD, I went for a few months to the Princeton Institute. Then the following year, I went to Caltech, and then I went to Harvard. So I've got to know various American institutions, and that was very educative at that stage.
Yeah, that's a very storied collection of our institutes as well. Now, you here at Trinity were the master of the college, ending quite recently, correct?
I was master for 8 years, 2004 to 2012. Well, my history is that I was professor and head of the Astronomy Institute until about that time, and then I took on these organizational roles at Trinity and President of the Royal Society, which is our counterpart of the American National Academy of Sciences. And also I became a member of the House of Lords, which is part of our parliament, and I've been a member of the Lords, and I spent 2 days a week there. So I've diversified from being a pure researcher in the last 10 or 15 years. But the plus of that has been that I've been more exposed to general policy and political issues, and that is why I have written books like my present one, which is not primarily on astronomy, but is on more general issues.
Yeah, and also in your role, is it the president of the Royal Society? Did I get that right? I mean, that is, first of all, the world's oldest national scientific institution, if I'm not mistaken.
Yes.
And you had some very storied predecessors there. Again, Isaac Newton and Charles Montague, if I'm not mistaken. And then I was looking through the history and I saw a Sir John Pringle. Is he the inventor of the vertical potato chip?
I rather doubt that.
Yeah, I do too.
But the history of the Royal Society, which was founded in 1660, is a history where, in the old days, science was done by gentlemen scholars. Ingenious and curious gentlemen was the word they used.
Oh, that's great.
No women there, no all men at that time. And it really only became professional academy from the end of the 19th century.
And you currently hold what is not merely my favorite title in your own CV, but maybe my favorite title of all time, which is Astronomer Royal. Mm-hmm. Now, what does that entail precisely?
Well, it entails very little at the moment, but the history is interesting because the first science to become professionalized, apart from medicine, was, of course, astronomy.
I didn't know that.
And I like to say it's the first science that did more good than harm. In the 17th century, various countries set up observatories for longitude and navigation, etc. And at Greenwich, we have our National Observatory. And the person who directed that, and it was set up in 1675, was called the Astronomer Royal. And so it was an observatory director. But in the 1960s, it became possible to build telescopes on clearer skies, clearer mountaintops overseas. And the museum at Greenwich, which already existed, the Maritime Museum, then took over the observatory as part of a museum. And so since it wasn't an active research centre, the title was then given to a research astronomer in a university, but with no duties. And I like to say the duties are so exiguous, I can continue posthumously.
You can continue posthumously. Well, you have this charming story of occasionally being asked if you are responsible for the Queen's horoscope.
Of course, astronomers always ask, are they astrologers, etc. And I like to say that I'd earn a lot more money if I was, I suspect. I do in my book tell a story of meeting a tycoon. And he asked me, do you do the Queen's horoscopes? And I answered with a straight face, if she wanted one, I'm the person she'd ask. And he then solemnly asked me for my predictions. And I said, equally solemnly, well, the stock market will fluctuate, there'll be trouble in the Middle East and other surprising things. And he nodded sagely. But then I came clean and I said, well, I'm actually just an astronomer. And he then lost all interest in my predictions.
Oh, no.
And of course, rightly so, because scientists are pretty poor as forecasters, almost as bad as economists.
Well, if he'd bet on volatility in the stock market, he might have done very well. I think
right.
You proved to be incredibly prescient about that. I want to focus primarily on the themes of your new book, On the Future, and what I consider to be its 2003 forerunner, Our Final Century, as it's called here in the UK,
yes.
and Our Final Hour, as it's called, I think, much less aptly in the United States. But before that, I want to just talk about a couple of the themes that you have studied in your long career in astronomy. I think it's over 500 papers that you published, so that covers almost everything. But I saw that you have done a little bit of work with gamma ray bursts, and those fascinate me because they are spectacularly, frighteningly violent. What could you tell us briefly about the gamma ray burst and whether we should be worried about one of these things?
I don't think we should worry much about them, but I think they are fascinating because they are indeed, as you imply, the most powerful sources of energy in the universe, where more energy than the sun produces over its whole lifetime comes out in a fraction of a second.
Wow.
And it's in a beam which is pointed in a fairly narrow range of angles. And if we're in that beam, of course, it seems even more powerful. And the theory of these is something which I've worked on since they were first discovered. And it's fascinating because we are starting to understand something about the physics. But it illustrates also that there's another reason for doing astronomy, apart from simply understanding what's out there. It's to find places where nature has done experiments under far more extreme conditions than we could ever do ourselves in the laboratory. A fine exemplar of this is the gamma ray burst, where the energy densities, the temperatures and all that are extremely high. So the motive for trying to understand what's going on in them, and indeed in other extreme phenomena in astronomy, is to test the laws of nature under extreme conditions, strong gravity, high energies, etc., which we can't do in the lab. That's one motive why it's so interesting to study these things.
And they literally, when they're going off, they can emit more radiation than the entire galaxy that they are hosted in. Am I correct in that?
Oh, by a huge factor, yeah.
By a huge factor.
Sorry, more power. It all comes out in a few seconds.
And if I'm not mistaken, there was one not terribly long ago that originated many billions of light years away, that if a person had been fortunate enough to be gazing at exactly that precise point in the sky, would have been able to view it with the naked eye?
Yes, most of the energy comes out in gamma rays, but some comes out in visible light. And as you say, the total energy is so great that even the fraction in visible light would have been detectable. So if you'd been looking that way, then with the naked eye, you could have seen an object 10 billion light years away.
10 billion light years. And that's only a tiny fraction of the energy.
That's right.
So what is causing that?
Well, it's probably the formation of a kind of black hole or collapsing star, or indeed the merger of two neutron stars or neutron star black hole, when material swirls down into some small volume and perhaps makes a black hole and produces very strong magnetic fields and a jet that squirts out at nearly the speed of light and produces the gamma rays. And there are lots of models of this. And of course, in all of these subjects, we've been hugely aided by the ability to do computer simulations, because we can't, of course, do real experiments on the cosmos, but in the virtual world of our computer, we can ask what happens if you crash two neutron stars together, etc., and test these theories. And it's by such computer experiments that we've learned quite a lot more. Gamma ray bursts were first discovered, incidentally, nearly 50 years ago, serendipitously, by a US satellite that was put into space to look for clandestine Soviet nuclear tests being done in space.
Really?
And this satellite discovered that there were unexplained flashes of gamma rays. And it took them 3 years to convince themselves that these were not of a sinister origin, but that they were natural phenomena from far beyond the solar system. And it took a much longer time, 2 more decades, before we realized that they were coming from far beyond our own galaxy, and that we started to understand them as being the cataclysmic end of the life of some peculiar kind of star. And there's been an interesting development in the last year or two when the LIGO gravitational wave detector detected evidence for 2 neutron stars in orbit crashing together and merging to make a black hole, and that produced a gamma ray burst.
Really?
And so one class of gamma ray bursts was already conjectured to be due to merging neutron stars. So this was nice corroboration of that.
This was hard evidence. Well, imagine how terrifying Khrushchev would have been if he had been able to trigger gamma ray bursts. Thank goodness that was not actually Soviet bedevilment up there. Now, you said it's a narrow angle that they end up broadcasting this radiation on. Is it just like 1 or 2 degrees?
Well, there's a big debate about the beam pattern, as it were. I think the best guess is that it's within about sort of 5 degrees, but there are sort of side lobes.
Well, this might seem a little bit beside the point, but this ties directly to the issue of existential risk, which is why I'm so interested in this.
Mm-hmm.
If the beam were directed precisely at us from a gamma ray burst, how far would we need to be from such an event to not be annihilated on our own planet? Like, how sterilizing is that beam?
Even if it was 1,000 light years away, it would disrupt the upper atmosphere and allow a lot of UV in, etc. But the rate at which these objects occur is much less than the rate of supernovae. So there's been lots of work done on the effect of supernovae over the Earth's history, and it turns out that the effect of gamma ray bursts is about the same. The reason for that is that the nearest supernova, since they're more common, is going to be about 10 times closer at least than the nearest gamma ray burst. And therefore, if you look back for the last million years, then the damage due to the nearest supernova is probably comparable to that due to the nearest gamma ray burst.
The damage to our atmosphere, but clearly
Yes.
we survived that. It was nowhere near as annihilating as an asteroid strike.
No, that's right. So if we think of cosmic threats, this threat, I think, is below the threat of asteroids. And of course, as I say in my book, not even asteroids keep me awake at night.
No.
Because these are threats which have been equally high for the Neanderthals as for us, and we can calculate these, and in future we might be able to deflect the asteroids. But the threats that we worry about now are ones which are caused by humans, and they're far more worrying than the natural threats.
Which precisely goes to the next question that I was going to ask you, which is, when did you first start getting interested in what some now refer to as existential threats?
Apart from astronomical work, I've been engaged with politics for a long time. And of course, I was, for that reason, naturally involved in talking about nuclear arms control and the nuclear threat. And I used to go on demonstrations, and I was involved in the Pugwash international conferences, which were concerned with getting scientists to try and promote arms control. From the 1980s onwards, I was interested in that particular threat, which of course is still a serious one. It may be in abeyance compared to the Cold War, but it may come back. So I think that's the first non-astronomical serious threat that I got involved in. But then, of course, through being in a university like Cambridge, where one runs into experts in biotech and AI every day, I got involved in others, and the opportunities I had through being president of the Royal Society and in Parliament meant that I had more chance and indeed more obligation to engage with these issues. And so I think that's how I gradually became more involved and have felt that these are understudied, because compared to the huge amount of study and concern that goes into the carcinogenic risks from foods and things like that, there's rather less effort going into the study of these newly emergent, potentially catastrophic threats. And especially in a university like Cambridge, we have an obligation to use our convening power and expertise to try and think about which of these can be dismissed as science fiction and which are serious enough that we ought to worry about, and to see if we can suggest how to minimize the downsides, while, of course, not losing the benefits which these new scientific advances always provide.
Well, my own first really rigorous exposure to the whole notion of existential risk, in 2003, your wonderful book, Our Final Century, as it's called in the UK, and Our Final Hour, as it's called in the US, to my great annoyance. And I just say, like, yeah, yours is as well. Our Final Hour sounds so melodramatic, but you were talking about the possibility that technology would run amok in the 21st century, not any particular hour of the 21st century.
I like to say America's like instant gratification and the reverse. Yeah.
And you wanted there to be a question mark as well, which there should have been, because you weren't saying it was definitely our final century.
No, and of course, if you ask me now, I think it's unlikely we'll wipe ourselves out, but I do think we will have a bumpy ride.
Yes.
For various reasons through the century, and that's the theme of the new book.
Yeah. And so I view the two books as being concerned with similar topics, and On the Future, your new one, which we should say comes out here in the UK 10 days hence as we sit here speaking on September the 25th, am I right?
About that time, yes.
And a little bit later in the United States, I believe October 15th. And one of the ways that you first introduced this topic is you talked about how we can and should very rationally make investments against a cataclysmic asteroid, unlikely as it is. And these seem to happen about once every 100 million years. But you did make the point in that book that when a risk is this cataclysmic and the cost is so vast, investments can and should be rationally made.
Well, it's an insurance policy. And in fact, although the dinosaur-killing asteroid is unlikely to come in the next few million years, there are, of course, smaller asteroids that impact more often, and it's worth the investment to guard against one of those. There was the famous Tunguska meteorite that hit in Siberia and flattened many square miles of forest, and something like that on a city would be catastrophic. And they're the kind of asteroids which are, say, 50 or 100 meters across, and it's worth having a project to track them and think of ways to deflect them. And in fact, this is not crazy. I mean, NASA is doing serious studies of how to do this.
Yeah, which is a good thing, because something like the Tunguska asteroid, if it hit, a major city at rush hour, would have millions of casualties.
Absolutely.
But even the highly unlikely once every 100 million years type of asteroid, when you do what's often called an expected value analysis, and you say there's 7.5 billion people in the world, and this happens once every 100 million years, you suddenly start realizing that this is the equivalent of something killing 75 people with 100% chance. So we do make significant investments to prevent such a number of deaths.
Well, I think this is very important, because this kind of threat is one where the biggest body count per year, on average, is from the very rare extreme events. It is true, as you just said, that about 100 people per year on average are going to die due to asteroids. And people might ask, well, in historic memory, no one's been killed by an asteroid. But the reason is that it's dominated by the rare events. And that is true of most of these catastrophic threats I worry about. It's rather like in the stock market. It tends to rise steadily for a number of years, and then it's a catastrophic fall. And when you have what's called a Pareto distribution rather than a Gaussian distribution, this is characteristic. And so one could be lulled into security falsely by thinking that things are fine, and then the big one comes along. And that's true of asteroids. That's also true of the other threats I discussed. But the extra reason why I worry more about the other threats is that their probability is going up year by year. As technology advances, the asteroid impact is measurable, but it's not getting any bigger
It's
year
steady,
by year.
yeah. We're not doing anything to increase our risk of an asteroid strike. But particularly when we talk about something that has the potential to be truly annihilating, I just quote something, I believe this is actually from Our Final Century. It would worse still foreclose the existence of a perhaps far larger total number of people in all future generations. Wiping out all the world's people and indeed destroying not just humans but the entire biosphere could therefore be deemed far more than 6 billion times worse than the death of one person.
Yes. Well, I think this is a very important philosophical point. And this comes up, actually, in my opinion, when we talk about climate change and what insurance premium we should pay for that, because climate threat is something which is getting worse. At the moment, it's not catastrophic, but it could become catastrophic if we get to a tipping point by the end of the century. And the debate about climate policy is not so much debate about the science. Everyone accepts that there's an uncertainty in the science, but it's really a debate about the ethics and a discount rate. Some people apply the standard discount rate that you would if you were deciding to invest in putting up an office building or something, where you want to get the money back by 2050, otherwise you don't bother. And therefore, in discussing climate, you write off any risk beyond 2050 and say, let's spend money that benefits people now. But on the other hand, other people would say, well, shouldn't we worry about the life chances of a baby that's just born as much as about our own? And if so, we should realize they will be living in the beginning of the 22nd century, and we should be prepared to pay an insurance premium now to reduce a potential risk for those people nearly 100 years hence. But then we can go one step further and say, should we perhaps worry not just about our immediate descendants, our children and grandchildren, but should we worry about the long-term future? And that does lead to this existential question, which I present in my new book as comparing two scenarios. One when 90% of people are killed, and another where 100% are. How much worse is the second than the first? One argument is, well, 10% worse, the body count's 10% higher. But the other is that it's incomparably worse, because if you wipe out everyone, then you foreclose an immense future.
Yes.
And therefore, people would argue that we should devote much more effort to addressing completely existential threats, even if they're very, very unlikely, because the consequence of wiping out the human species should be regarded as far more serious even than a catastrophe that wipes out most people. So that's an ethical question, really.
And particularly when you think of the enormity of the plausible future. I mean, if
That's
we
right.
do escape the confines of Earth and go on to colonize the galaxy and even distant galaxies, our descendants could number in the octillions, and numbers that are larger than octillion whose names escape me at the moment.
Yes, that's right, because some people do argue this. I mean, my friend Nick Bossum at Oxford, he argues like this. I think one shouldn't take this argument too far, because you have to ask the other question, are there any aliens out there already?
Right.
It could be that, supposing that there are aliens out there and supposing that they are more advanced or more admirable than us, then expansion of humanity into their environment might make a negative contribution
Good
if
point.
it squeezes them. And so the question of the extent to which it would be a good thing for humanity to spread beyond the solar system is a question which depends crucially on whether there are aliens out there already. And of course, that's a question which we astronomers are asked most often.
Yes, of course it is.
And which we can't answer.
Which, of course, you cannot.
Yeah.
But it is also, there's another interesting moral dimension. If there are no aliens out there, if life is so extravagantly rare in the universe that intelligent life is even more extravagantly rare, and ergo we are the only sentient species anywhere,
Yes.
then the tragedy of exterminating ourselves becomes, morally, it seems, far greater.
Yes, I think most people would take that view. And then to put another gloss on that, there's another issue which comes because we are not the culmination of evolution. So we have to say that if we snuffed ourselves out, this would not be just snuffing out humanity, it would be snuffing out potential post-humans, even if you're really misanthropic and you didn't think humans were worth preserving. And there are some people like that. But you would say it's rather like if you clobbered the first fish that went onto dry land. It may have looked rather unprepossessing, but you'd have destroyed the future of land-based life. And in the same way, if we were to somehow snuff out the human species, it would destroy these huge potentialities. But then, of course, this leads to another theme of the book, which is, does the future lie with organic intelligence or electronic intelligence? And I think I would argue that, especially if humans have started to colonize the planets and are in environments that aren't particularly well adapted to the human body as it now is, then they want to use genetic engineering and cyborg techniques, and they might download themselves to electronic entities. Then the far future may lie with those machines. But then there's, of course, a question which is philosophical. Do these entities, which are quite differently constructed from us, are they conscious in the same way as we are?
Yeah.
I wrote an article about this in a magazine a few years ago, and I got a bimodal response. Some people said, isn't it great that there be superhuman things that can appreciate and understand the universe more? Whereas others took the line that these machines will just be zombies. They'll have no self-awareness, etc. And so there'll be nothing to appreciate the beauty of nature. And so it's a bad thing if we are superseded by these electronic entities.
That presumes that they are unconscious electronic entities. The zombie scenario does.
That's right, because there is a big debate about whether consciousness is an emergent property of any complex system or whether it's something peculiar to the kind of wet hardware we've got in our skulls. We don't know.
We don't.
But of course, developments in computer technology and AI, where one is getting to the stage where we can envisage brains with the computer power of a human brain, then of course we do have to ask these sorts of questions. And then of course you ask the question, could we download our brains into something electronic, which would then be more powerful and think much faster than we do? Some people are quite relaxed about this. Mr. Ray Kurzweil, who works for Google, in particular does this. But of course, this is an old philosophical question of personal identity. Supposing that you were told that your brain had been downloaded into some machine, would you be happy to be destroyed yourself? And then what happens if, for instance, they make multiple copies of you?
Yes.
Which one is actually you? So all these questions, which philosophers have debated for ages, are now becoming topics that might be relevant to technology in this rest of the century.
Yeah, and certainly to people, maybe the youngest people who are alive today, but certainly with the rate with which technology is improving, at least in the lifetimes of some people, these could become very, very real issues. I always sort of thought that if there was sort of a relay baton-like handoff of my consciousness, I'm beaming onto this planet, and the former Rob Reed vanishes and the new one takes form on the planet instantaneously, and then I upload to a computer, and there is a smooth handoff there, that would feel like a continuous consciousness. But as soon as one of you is left behind and informed, oh, by the way, the other guy's got the baton and you're about to be destroyed, the morality of it changes radically. Now, you have carefully and appropriately said, we don't know these things. But I can't help but ask you what your own intuitions are. First of all, a digital entity, an intelligence, do you imagine that that would be imbued with consciousness? Is that your own instinct?
I think it's certainly possible it would have a sort of self-awareness, because the most convincing argument that I can think of for why consciousness emerged was that it's got huge evolutionary benefit if we can think through scenarios before we actually act. Before I hit you on the head, I might think through what might you do if I hit you on the head, and then decide not to do it. And so in the same way, you can imagine that the capacity of machines to explore a variety of scenarios is going to be something which is beneficial to their survival. But on the other hand, I don't go all the way with those who think that AI is going to take over. And certainly there won't be expansionists, because the feature of Darwinian evolution is that it's favored two different qualities. One is intelligence and the other is aggression. And if we have machines, then, of course, we want them to become more intelligent in the sense of being able to do more, but we don't want them to be aggressive. And there's no particular reason whatever why entities that haven't been involved in anything like Darwinian evolution should become aggressive. And for that reason, I think one can be slightly more relaxed than some people are about the danger of the machine taking over. And, of course, we know that the way we think and are aware of the world is because of our particular senses. And it's not obvious that the machine will have that same perception of the external world.
Yeah, it's interesting. There is a lot of talk amongst those who think about consciousness, it seems, about whether the experience of a limited, finite, physically constrained body is in some way an essential ingredient to the emergence of consciousness. And it is definitely one of those great unknowables.
Absolutely, yeah.
One of the most powerful passages to me, you talked about the possibility of science experiments run amok. And again, extravagantly long odds, yet possibly extravagantly terrible consequences. Yes. Could we talk very briefly either about the specific experiment? I think it had to do with strangelets, and it had to do with something going on at CERN. What could possibly have gone wrong in that scenario, and or what might go wrong in future scientific scenarios, which, however unlikely, cannot be ruled out?
Well, there are scenarios which physicists are imaginative that could lead to catastrophes, and in particular, when a new and more powerful accelerator comes online, then it's reasonable to think about, could it do something that hasn't happened before that could have drastic runaway consequences.
That hasn't happened anywhere in the cosmos even.
Well, indeed, yes.
Tell me if I'm wrong about this, but I understood from your writing that gamma ray bursts notwithstanding, we are capable of creating circumstances here on Earth in our laboratories that, as far as we know, have never existed anywhere in the cosmos.
We are, or we may one day be able to, yes. And there are a number of scenarios. One is that ordinary material might be changed into something called strangelets, which would in effect destroy all structures on the Earth. And the most catastrophic of all was the concept which was put forward by a Harvard professor called Sidney Coleman, which was that you could rip apart the fabric of space itself. Then you'd make a new, what's called a vacuum in technical parlance, where the physical laws were quite different. And people talk about a sort of phase transition. This is rather like if you have super cool, very pure water and you put a bit of dust into it. Then
let's talk about that, because I don't know if everybody knows what supercooled water is. I didn't until I read your book.
Well, it's possible to freeze water down to below the ordinary freezing temperature, and if it's very, very pure, then it won't turn into ice. But then if you put a bit of dust into it, then the ice nucleates around it and it quickly all transforms into ice.
It's like Ice 9 in that Kurt Vonnegut novel. It's just suddenly this thing which was very happy being water with a tiny impurity, everything changes and now it's all ice.
Yes. And Sidney Coleman et al. Speculated that there could be some transition like that for the whole of space. The reason that this is something physicists talk about is that there's a great deal of discussion in cosmology about the nature of empty space, and when we discovered 20 years ago the universe was accelerating, that meant that there was some force latent in empty space which was pushing an overwhelming gravity on the cosmic scale, and that therefore means that empty space has some complicated properties. And many of the theorists who worked on this think that there may be a lot of variance of empty space, and we may not be in the lowest energy one. Again, it's very, very speculative, but we can't absolutely say no. I think it's fair to say that before we do any experiment which takes us into a regime where nature hasn't done the experiment already, we ought to think pretty hard and be careful. This is true in biology. If you create some new dangerous pathogen, you ought to think very hard. But I think there is a proviso, which I make in the new book, which is that even though there may be some unforeseen negative consequences from these new experiments, there could also be some unforeseen benefits. We don't think that these experiments will solve the world's energy crisis, but they might. And this leads to the general issue of the so-called precautionary principle. To what extent do you reduce the risks if, at the expense of so doing, you are missing the chance of some positive developments?
So to get to something that is on more radars than the possibility of a strangelet emerging from a super collider, you've discussed the risks posed by synthetic biology quite extensively, and earlier really than most people had.
Of course, we know that biotech is advancing very fast. We also know far more than when I wrote my first book what can be done. And I give two examples. One is that in 2011, two groups, one in the States, one in Holland, showed you could make the influenza virus both more virulent and more transmissible.
The so-called gain-of-function experiment.
Yes. And the US federal government for a few years stopped funding these because the risk was that these could get out of the lab and it was dangerous knowledge anyway. So that's one example. And of course, the huge advances in gene editing, etc., give more opportunity to do things like this. But the important point is that unlike nuclear technology, these technologies require the kind of equipment which exists in many university labs, many industrial labs. And also, there's lots of commercial interest. If we go back 45 years to the early days of molecular biology, recombinant DNA was invented, and there was a famous conference in Asilomar where the experts tried to decide should there be a moratorium on some kinds of experiments.
Yeah, that was a remarkably foresighted and active group responsibility. It was in the 70s, correct?
That's right, and it was led by David Baltimore and people like that. And in retrospect, they were slightly overcautious, but it was a good thing that they did this.
Better to err on the side of caution.
Absolutely, yes. And there have been analogous efforts made more recently by inter-academy groups, etc., to address this problem, which is now more acute because of these more powerful new technologies, and indeed to suggest regulations. It's very good they're doing this. But I think there's a difference, which is that now the technology is far more widely dispersed. There are far more nations involved, far more labs involved than there were in the 1970s, and also there are strong commercial pressures. So the reason I worry about biotech is that anything that can be done will be done somewhere by someone, even if we try to impose regulations. Enforcing those regulations globally is, in my view, as hopeless as enforcing the drug laws or the tax laws globally. It had not much success in either of those. So I do worry that either bioerror or bioterror could lead to something very serious, which could cascade very widely.
And there's just a very different level of proliferation that happens versus nuclear, which was certainly the great fear.
That's right. In the case of nuclear, it's very dangerous. But of course, you can't do nuclear technology without conspicuous special purpose facilities. So the feasibility of regulation is far higher in the nuclear arena than in the case of bio.
Also, to inflict a general catastrophe, even an annihilating catastrophe, on the world using nuclear is something that no more than 2 or 3 people will presumably be in a position to do.
That's
because
right.
It would take the resources of not merely a nation state, but a truly mighty nation state to be able to put us all at risk.
Put all at risk, yes. Of course, during the Cold War, there were 70,000 weapons on each side. They could have gone off. There are now 10 times fewer nuclear weapons, which is progress. So I think the risk of that sort of catastrophe is less, although the risk of a few nuclear weapons going off in the India-Pakistan conflict or the Middle East is probably higher than ever before. But I think, as you say, the difference is that the nuclear threat does require large organizations, whereas a serious bio threat could emerge from just a few people. Now, of course, because the consequences of any bio attack are so unpredictable, bioweapons are not generally going to be used by any nation states, nor even by any terrorist group with well-defined aims. So my worst nightmare in this area of concern is about the fanatic environmentalist who thinks that Mother Earth is being destroyed by too many human beings and would therefore think it was good for Mother Earth to have fewer human beings. It wouldn't care who was eliminated. And so one person like that would be too many.
Or the radical misanthrope. In the United States right now, I believe over the past year, we've had something on the order of 1 mass shooting per day on average, a little bit less than that, but close to that. And when a certain small, mercifully small, but we'd like it to be smaller percentage of people do take their own lives in any given year, about 1 million people worldwide, and a mercifully small, but not non-existent percentage of those people have a terrible malfunction which causes them to want to exterminate as many strangers as possible as they're going out. And we seem to have quite a number of those recently in the United States. And it seems to me that when such things happen, when somebody gets to that point of extremity, the force multiplier really is technology.
Yes.
To quote a sort of ghoulish statistic that I happen to be aware of, there was a series of mass stabbings in China a few years ago. It was about 10 or 12 of them. But bizarre coincidence, the final one was just hours before the terrible Sandy Hook incident in the United States, in which one person went into a school and shot dozens of very, very young children. The combined death toll of all those 10 or 12 mass stabbings in China was roughly equivalent to that of Sandy Hook. There's this great force multiplier in technology when somebody goes off the rails if they have a machine gun, as opposed to hammers and knives, which are the most deadly retail items that are available in China. There are going to be more deaths. And of course, the grim case of Andres Lubitz, the German wings pilot, he was armed with an airplane, killed 150 people. And so when we look at this compounding curve of rapid expansion in capabilities that we have in synthetic biology, which is much faster than anything that we've seen in computing, and we think about the radical environmentalist or the radical misanthrope and think of what that person might be capable of, not today, not next year, but 30, 40, 50 years hence, there is a very, very different level of proliferation.
Well, indeed, this is very concerning, and I don't see any way to actually eliminate this. We can try and reduce it by a number of ways, but I think it's going to pose a growing difficulty in reconciling freedom and security and privacy. We're going to have to balance those in some way, and that's going to be more and more difficult as we realize that a few people can have catastrophic impact.
And also, as we certainly saw in the nuclear era, a race dynamic, 2 sides trying to beat who they consider to be the bad guy to the punch, can lead to tremendous instability. And it was bad enough when the Soviets and the United States were racing each other to develop more and more diabolical weapons. But when you potentially have dozens or even hundreds or thousands of actors in a synthetic biology realm, in which it might be two perfectly decent and benign professors racing each other in one case, and it might be a national race between, let's say, China and the United States in another case, and Google versus somebody else in another case. Everybody is sprinting headlong. And even if they all have the most benign of intentions, but are concerned about somebody else beating them to the finish line, that also leads to a great deal of instability.
Well, absolutely. People then take risks.
Yes.
I don't see how we can eliminate these, but I think what we can do is raise consciousness, make sure that ethics is part of the education of every scientist, and, of course, do what we can to minimize the risk, just like in cyber attacks. But I think we're going to have to devote more and more effort to eliminating, or at least reduce, the risks of the maverick.
One other thing on the future in your new book you mentioned as being potentially in the hands of mavericks is geoengineering. And this ties to what we were talking about earlier with respect to climate risk. What do you see as being the danger there? And do you see any potential at all in the domain of geoengineering?
Well, let me first say what I think is going to happen on the climate front generally. I think climate science is pretty compelling in saying that we are heading for a warmer world induced by burning of fossil fuels. The rate at which the warming goes is uncertain by a factor of 2. And I think in 20 years from now, the CO2 emissions per year won't have gone down, so we'll have more warming. And we'll also, by then, have a better understanding and a longer time base. And if things are at a low level of the IPCC projections, we can relax a bit. But if they're high, then there may be pressure for some sort of plan B to avoid going over tipping points when things could run away in an irreversible way. And this will lead to the idea of geoengineering, which is where you, for instance, put some material in the upper atmosphere which blocks out a bit of sunlight, and there are other ideas.
So it essentially you try to hack the atmosphere itself,
That's
or hack
right.
the climate itself in a deliberate way. We're doing it inadvertently now with all this CO2.
Yes.
But this is like, let's fix it.
That's right. And of course, there are two problems with this. One is that we may not understand things well enough to know the side effects of any such intervention in the upper atmosphere. And also, there would be different views among different nations. I mean, Siberia might like to have a slightly higher mean temperature, so different countries would want to turn down the thermostat to different extents.
Right.
And so if these technologies were feasible, then it would certainly lead to a new type of international conflict where only the lawyers would benefit because they would, for the first time, be able to have litigation about bad weather, which they can't now. But I think more seriously, there are technologies which could block out 2% of the sunlight getting to the Earth or something like that. And the frightening thing is that these are feasible enough and cheap enough that they could be done by one nation, even by one corporation. And so it's not obvious that if this happened, it would be done after international agreement. And so that sort of geoengineering is something which we should hope we never need to take seriously. But in the meantime, I'm slightly in favour of some sort of research and development, so we do have a better idea of what is feasible and what isn't. And there is another kind of geoengineering which everyone would agree is a good thing, and that is simply sucking the carbon dioxide out of the atmosphere.
Carbon sequestration.
Yes, that's right, which can be done in power stations to avoid putting more in, but could in principle be done in the air by just sort of processing all the air through something and filtering out the carbon dioxide. The latter is feasible but takes a lot of energy.
So you'd have to put a lot of air through that, but you would find that less controversial because at that point we're undoing something that we've already done. Is that why you think it would be less controversial?
If that's feasible, I think most people think that was okay.
Yeah.
But the other kind, where you change the global weather patterns by putting something in your upper atmosphere, that could have downsides.
Yes.
And will be very dangerous. So I think if we look at what we should do about climate change, I think it is a big problem. The reason it's such a difficult problem is that we are addressing a threat which is, like the other ones we've discussed, fairly distant in the future by normal human standards. The worst effects are going to be by the end of a century. But the other point is that the effects are globally spread. So you're asking politicians who normally focus on the local and the short term to make sacrifices for the benefit of people in other parts of the world far away 50 years from now. And that's a hard ask. But the faster we do the research and development, the quicker will we come up with good ideas, and the faster will the cost come down of these alternatives. And if we think of, say, India, where they don't use much energy now, they naturally want more energy and they want some healthier way of generating it. And their first move will be to build coal-fired generators. But if it ended up that the clean energy was as cheap as a coal-fired power station, then, of course, they would voluntarily choose to leapfrog directly to clean energy. And I say it's a win-win situation because obviously it's better for those countries which can buy cheap, clean energy, but also, obviously, it's a new technology which will be very profitable for the countries that develop it first.
Made me think about something I hadn't thought about before, which is the proliferation risk with geoengineering. If the technology becomes well enough understood and affordable enough or even trivial enough technologically, there could be a lot of people grabbing for the thermostat. And they don't need to ask anybody else's permission. You had said it could just be one country doing this. It could be a corporation doing this. And maybe in an extreme scenario, a century or so hence, it could be a very small, motivated group of people. And that is a reason to worry about geoengineering, however much faith we might have in a global effort to really understand the consequences of geoengineering and do it just right and do tiny experiments and really figure out we put this much reflective matter into the atmosphere and we're going to be fine. If Siberia really wants to turn the heat up,
yes,
and Equatorial Africa really wants to turn the heat down, and 17 people have 17 other opinions, and they're all grabbing the thermostat without talking to each other.
Yes.
That's when you could have a real runaway.
But I think that leads to another environmental issue, which is a byproduct of CRISPR and these other techniques, is what's called gene drive, which has been used already to make a kind of mosquito sterile.
And gene drive, just to explain it briefly for those who don't know.
This is where you put some modification into an insect or an animal which is inherited. And so you can eventually affect the genome of an entire species.
And inherently proliferates very widely within the species.
Within the species,
yeah,
yes.
Because it becomes a dominant inheritance.
Yes, and this has been done with this mosquito species to make it extinct.
Yes. And rather quickly, correct?
Well, indeed. But of course, there are risks of this sort of tinkering with the ecological balance. This is just an example of something which could unwittingly cause serious ecological disruption.
And again, because we're no longer talking about nation states with nuclear power, nor are we talking about enormous emissions in geoengineering, this is the kind of thing that could proliferate down to the level of a tiny, tiny group eventually.
That's right.
Gene drive technology is already reasonably understood and reasonably well documented out on the internet. And the DNA synthesis techniques that will enable more and more refined gene drive are accelerating at rates that even Moore's law has never seen before. It again becomes something that many, many people may just take it upon themselves, perhaps even with the best of all possible intentions, but unleashing something. Just because I haven't brought up enough morbid topics, another thing in your new book on the future that really made me think very hard, although we are much more robust in many ways with the modern technologies that we have, we are also so accustomed to our security and our safety that we are paradoxically far less robust. Humanity sort of powered through the bubonic plague, which could kill a third or a fifth or a quarter of the people in a city. You make the point that a tiny, tiny fraction of that kind of casualty would just knock us on our tailbone.
Well, I think once the capacity of hospitals was overwhelmed, which could happen with less than 1% of cases, then there will be serious social breakdown. And of course, quite apart from that, we are vulnerable because we are more interdependent and supply chains will be broken down, etc. Just as we're vulnerable to cyber attacks, which could close down a country in a catastrophic way, so we're vulnerable to a greater extent to pandemics, natural or artificial, even if the proportion of people who actually succumb is lower than it was for the Black Death.
Yes.
And of course, another point I'd make is that if we think of the Black Death or the kind of cases which Jared Dahmer discussed in his book Collapse, what happened in all those cases was there was some disaster in some region, but in no case was it completely global.
Right.
And if we had some very serious disruption now, that I think any effect would be global.
And our tolerance for morbidity has just plummeted. And what a wonderful thing. And we're all very grateful for it. But we talk about, you mentioned a 1% casualty rate, which is quite trivial in relation to many things that humanity has endured. My city of New York, that's 70,000 people suddenly dropping dead. We have no frame of reference for that. Not even 9/11 was literally not even a tenth of that. It's maybe 3% of that. And that was obviously very, very scarring. it would definitely thrust us into a completely different realm. You mentioned cyber attacks, and we talked briefly about artificial intelligence. You are less concerned than some people are about a runaway AI scenario, in part for the reason that you mentioned that you don't see aggression
That's right.
becoming part of...
But I do worry in the short term about cyber.
Yes.
Of course, there are different levels. There's a kid in his bedroom, and we've seen examples of that. But of course, there are state-level attacks. And in fact, I quote in my book Department of Defense document from 2012, which talked about how a nation could close down and hold down the American electricity grid. It said in this document this would merit a nuclear response. And indeed, it would be catastrophic because the lights going out is the least of your problems. You lose transport, you lose water supply, you have no elevators in tall buildings.
Your food all spoils very rapidly.
Yep, absolutely. So it couldn't last for more than a few days without anarchy breaking out. And so this is the kind of thing which may seem unlikely and we're complacent, but one occurrence is too many.
Yeah. You made a point in the book that it's very important not to confuse the fact that something has never happened yet with impossibility.
That's right. Yes.
There was a power outage. This is a long time ago now, maybe 10 or 15 years ago when I was in San Francisco. And it was a minor power outage. It was during the daytime. And what just didn't occur to me until I was in the midst of it was that all traffic simply stopped because of the lack of signaling.
Yeah, that's right.
And, when you think about the scenario of a power grid being taken out by some diabolical actor,
yes,
if it were nationwide, I could certainly see how things as extreme as a nuclear response would come onto the agenda very quickly. I mean, no society is much more than 6 or 7 meals away from a revolution.
I think that's now high on the agenda, and they are doing the best they can, not for great success. But I think this class of threats is one which tends to be underprepared for. Because, to take an analogy, we pay for fire insurance on our house, even though we think it's unlikely. But that's because we know every day of other houses being burnt down.
Right.
Whereas in the context of these national or global scale events, they may be as unlikely as our house burning down, but we don't have any other examples. And so that's why we tend to be complacent and forget about the risk and rate how serious it is, even though it is worth a very high insurance premium to reduce it.
What to me as a reader is relieving. You seem to have come to being less concerned about a total annihilation today, perhaps, than you were 15 years ago. But as you said earlier in the interview, you foresee a very, very bumpy ride.
Indeed, I think civilization is much more vulnerable now, partly through things that have come about since I wrote my book. I mean, the dominance of social media and the dependence on the internet, which makes us more vulnerable, and panic and rumor can spread more quickly, and therefore any disaster which is local will cascade globally much more quickly. To that extent, I think that recent developments in technology have made me more worried, and ditto, of course, the rapid advances in both biotech and in AI.
Well, I would like to close by returning to your background in astrophysics and pose to you obnoxiously a great imponderable that you mentioned that everybody always asks astrophysicists. What does your own intuition tell you about whether or not we are the only intelligence in this vast cosmos, or at least in this galaxy?
Yes. It's not widely realized, but it's true that although we understand a lot about how life on Earth evolved from simple beginnings via Darwinian evolution, we still don't understand how life began. We don't understand the transition from complex chemistry to the first metabolizing, reproducing entities that we call alive. We have also, in the last 10 years, realized that the night sky is much more interesting in that most of the stars we see are orbited by retinues of planets, and there are probably many, many millions of planets in our galaxy which are rather like the young Earth. And of course, we'd like to know, was life such a rare fluke that we would only expect it to happen once where we are, or would we expect it to happen in these other places? Well, I think we will have answered that question within 10 years in two ways, either by the more serious biochemists working on the origin of life being able to decide how likely it is and how it happened, but also by being able to make observations of some of these planets orbiting other stars, which are precise enough to at least tell us something about the atmosphere.
We'll see biosignatures, both with the James Webb Telescope and one of the poetically named extremely large telescopes,
yes.
right? It is the literal name, right? Extremely large telescopes.
It is, yes. We are unimaginative in our nomenclature in Europe. Yes, that is impressive. It'll have a mirror which is 39 meters across, mosaic of 800 bits of glass, and that will get enough light from one of these exoplanets to perhaps see what the chemical composition is and whether it's green, whether there's any evidence for a biosphere, and also to actually see if there are continents and oceans. Because
really? We could get to that level of granularity?
Well, it doesn't need granularity, because let's imagine that someone with a very large telescope was looking at the Earth from 30 light years away. Then it would be Carl Sagan's pale blue dot. But the shade of blue would be slightly different depending on whether the Pacific Ocean was facing you or the landmass of Asia.
And with the movement of the planet over time, you'd be able to infer. There is both land and ocean here.
Land and ocean. And
you wouldn't have a map. You wouldn't say, oh, that's Bogota, Colombia right there. But you'd be able to infer the presence of continents
and land masses and the length of the day and something about the climate. And that's the kind of detail we will have within 20 years or maybe even 10 years about other planets. And that will tell us whether there's a biosphere. Actually, you went to imaging the planets. That's something in the further future, because that will require telescopes far, far bigger even than the extremely large telescope. When we have robotic fabricators that can build structures in space under zero G, and you can imagine very, very lightweight, huge mirrors, maybe a kilometre across, assembled by robots up in space, and they will be able to actually image one of these planets in 2068, which is a centenary of the iconic picture of the Earth from the moon. We might have a picture of another Earth, which we can put as a poster on our wall, and that would be really inspiring.
And that picture of the Earth, Earthrise, I think it was called, right?
Yes.
It really changed people's perspective. I loved that in your book when you made that point. I'll be 103 then, so I think I need to start eating my Wheaties. It's not quite out of the question.
Yeah.
To be able to see that image would be a really, really dramatic thing.
It would indeed.
Yeah.
But of course, the other question is whether it's not just a biosphere, but whether there's intelligent life. That's a separate question.
Giant, right? And so that's the thing that puzzles me the most when I think about the history of life here on our own planet. It seems that simple life arose almost as quickly as it could, just a few 100 million years into the Earth's history, correct? But then it was billions of years that we had single cellular life.
That's right.
For the vast majority of Earth's history, billions of years. So it would seem that that jump from simple life, so if we look out there and we see signs of methane or oxygen and exoplanets' atmosphere that would appear to be definitive or near definitive proof of a biosphere,
yes,
we still will not know whether it's made what was for us a 3 billion year jump. And when something happens once every 3 billion years, that's less often than we get hit by asteroids. And so that could be a really massive chasm.
But then, of course, late evolution is still uncertain, because many biologists debate whether if you were to rerun evolution and the asteroid didn't wipe out the dinosaurs, would we have ended up with intelligent life of some kind?
Sure.
Were there any contingencies which were crucial and were rare on Earth? We don't know. But I think we should look for any evidence for anything that's manifestly an artificial transmission or an artificial artifact in space.
As indeed we are with SETI and some of these other projects.
SETI, yes, and I think they're supported mainly by private benefactors, and that's fine. I wouldn't be averse to some public money being spent. I think there's a larger public support for this search than there probably is for building big accelerators. But of course, we then ask the question, if we do detect something which is evidence of artificial action, then what is it due to? Is it a civilization like ours or not? And I would argue, and I argue in the book, that it's unlikely that we'd be directly detecting a civilization like ours. And the reason for that is that if we take the one example, namely this Earth, then we know, as you said, that it's taken nearly 4 billion years to get from the first life to us. We know that within 1 or 2 centuries from now, it's possible that machines will have taken over. And so if we were to detect something odd around another planet, it may have had life like us on it 1 billion years ago. It may have something quite different now. So we may be detecting some kind of machine that was made by some long-dead civilization. And
we're going to fall silent pretty quickly. I mean, the amount of radio transmissions that we emitted as a civilization, surely now while we're doing everything by fiber optic and so forth, we're probably getting much less leaky and much less loud. We probably only had a period of a few decades where we were really making a huge racket, right?
That's right. And of course, people focus on the radio because that was the first technique that had the potential sensitivity. But as you say, it may be that that's not the way that we should detect these things at all. It may be something quite different. We may detect some strange artifacts orbiting around in the asteroid belt. We should look for those as well.
And from time to time, we think we found one, right? You talked about something I had never heard of in the book, which was delightful. Fast radio bursts. Did I get that right?
Yes, that's right. We talked about gamma ray bursts earlier, but there's a new phenomenon called fast radio bursts.
How new? When did we discover this?
First one was found 10 years ago.
That's new.
Yep,
Yeah.
that's right. And now several dozens have been found, and there are two categories, one which repeats and one which happens just once in a catastrophic way.
Wow.
These are not understood at all.
We have no notion of a natural phenomenon that would emit these for now.
Well, we can think of possibilities. It doesn't violate any sort of obvious, but they're another example of a new surprise, which were found serendipitously.
A final topic, because I hadn't realized you'd done work on this until I did a little research. I mean, I've done a lot of research about you, but I did a little bit more today, and I was delighted to find that you have been quite interested in the anthropic coincidences for some time.
Oh, yes.
I'd love it if you could take us on a quick tour of those to give everybody something really fascinating to ponder.
You mentioned one of my old books, The Final Century. I wrote another one called Just Six Numbers, which is the strength of gravity and nuclear forces and things like that. And the value of these numbers affects the details of the way our universe evolves. And if you imagine tweaking these numbers, then you end up with a rather different universe. And if you tweak them too much, you may find a sort of sterile universe where you get no chemistry or
no stars would form.
No stars. I'm still interested in this because I think it's an example of counterfactual history. Just like some historians would ask, what would the world be like if the Brits had been more intelligent in 1776 and had kept you as a colony?
Oh, it would be terrible.
We can ask, what would the universe be like if the gravitational force were a bit stronger or a bit weaker, or the other forces were different, etc.?
The answer is, if these six variables were tweaked, not just a lot, but a tiny, tiny, minuscule fraction, we would likely be in a sterile universe. Am I correct?
It's sensitive to one or two, like the strength of gravity. If gravity was 10 times weaker, it'd be even better. You'd have bigger and more long-lived planets.
Yeah. But some of them are minuscule, right? Like very, very precisely set.
Some are fairly precise, yeah.
And these variables are set, quote unquote, almost randomly in the conditions that immediately follow the Big Bang?
Well, we don't know. I mean, they're not explained in terms of any fundamental theory, but it's true that there's a certain range within which they have to be in order to allow the various chain of events that allow emergent complexity to happen.
And lo and behold, they are.
There they are, yes.
Yes.
You could imagine a universe where there's no periodic table of elements, or when stars aren't stable and things like that, or when the universe collapses before there's time for stars to evolve, etc.
Right.
In fact, I wrote my first paper on this in 1969, so
Really?
I go back a long way on this subject. But I think the other motivation for this is that there are some theories, particularly string theory, which do suggest that there are different kinds of vacuum. We talked about this in context with tearing apart the fabric of space by an experiment. And there are lots of theorists who think that there are many different possible forms of empty space. And our universe cooled down and settled into one of them, but there could be a multiverse where there are many, many Big Bangs.
Right.
And the other ones may have cooled down differently. And they would have ended up with different kinds of empty space within which the laws of microphysics would be different.
Mm-hmm.
And so if you believe that there could be a multiverse, and this again is an open question, and I know you talked to Priya about this, and I would agree with what she said, that it's something which we can't settle yet, but I think if we had a theory which allowed us to address the extreme physics that prevailed at this very, very early stage in the universe, then we would know whether a multiverse was likely to exist.
The question almost becomes more fascinating if we decide that there is no multiverse, correct? Because if there is no multiverse and there's only this one, then we have to wrestle with the question of why is it so immaculately tuned?
Yes.
That would seem to be an extraordinary coincidence. I mean, a very fortunate one. And of course, we wouldn't be here to ask this question had it not come about. But when you have an N of 1, it gets more puzzling if that N of 1 happens to be immaculately tuned to one's own existence. And I think we probably wrestled with that with planets going way, way back. Probably religion was more or less universally accepted for a period of time because people would look around and the physical world seemed to be immaculately tuned to what we needed to be around. And lo and behold, we're here. And then as time goes forward, you realize, well, there's trillions, quadrillions, quintillions of planets out there. So of course, one tiny, 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 tiny fragment of the planets is going to be Earth-like. And in fact, I think you had a statistic in your book that we currently think roughly 1 billion planets in this galaxy alone are in the habitable zone.
Yes.
Lots of shots on goal. At some point, the ball's going to go in the net.
Yes.
But if we only have one shot on goal with the universe, then its immaculate tuning is pretty weird.
Yes. Well, I think many people have exaggerated the fineness of the tuning.
Okay, got it. That I did not realize.
Well, I think the point is that what's the range within which some kind of emergent complexity is possible?
Yes.
Okay. And that allows a slightly wider constraint.
Or an intelligence of any kind.
Yes. But still, obviously, it's only a range of parameters. To take an example, if you had a universe which consisted just of 10 particles or nothing else.
Yes.
Clearly, it could not be very
finite,
complicated.
yes.
Yeah. Or if it expanded so fast that particles couldn't stick together in any way. Ditto. And perhaps also if there was no chemical periodic table, if there was just hydrogen. In fact, I discuss in one of my papers the idea, what I call the nuclear-free universe, where everything else is the same, except that there's no nuclear force and it's just hydrogen. You'd form stars and galaxies the same way.
You would.
Even giant planets.
Yeah.
But you wouldn't have any complexity. So I would say that universe would bear the same relation to our actual universe that a marble statue does to a real human body.
That's a great
analogy. It would look the same in big scale, but it wouldn't allow any complexity. So you can imagine all these counterfactual universes. But as you say, still there has to be a range of parameters outside of which you couldn't expect any emergent complexity. But of course, it could be that universe is part of some grand ensemble and it rings the changes on all these possibilities. And then we should not be surprised at being in one that does allow at least a level of complexity that we have depended on.
Much as our planet is one of a grand ensemble, and so the uniqueness of the planet has less philosophical weight when we realize how many planets there are out there. Do you believe we'll ever be in a position to do an experiment that could definitively answer that whether or not there is a multiverse, or will this forever be sort of a philosophical question?
No, I think we can do better. The point is that at the moment, we've got an understanding of the Big Bang back to the first nanosecond.
Which is unbelievable.
Which is amazing. And when I was a student, the idea of whether it was a Big Bang or not was still controversial.
No.
But now we have, to 1 or 2% precision, physics back to a nanosecond. Now, the reason I stopped there is that that's the time when all particles have about the energy we can produce in the LHC accelerator at CERN in Geneva. Going back further than that, it's outside the range where we have any direct experiments. But what we might hope to have is some theory which applies back at these very, very early stages, a trillionth of a trillionth of a trillionth of a second after the Big Bang. And if we have a theory which applies back then, and which has consequences we can test, if it predicted the mass of the proton and the electron, why there are 3 neutrinos, things like that, then we would gain confidence in its predictions, even in domains where we can't directly observe them. People think sometimes we've got to be able to verify all the consequences of the theory. That's not true. To give an example, we believe Einstein's theory of gravity because it's been tested in many places. We can't test what happens inside black holes. We believe that we understand what would happen inside a black hole because Einstein's theory has been vindicated in lots of other ways. So we take seriously what it predicts when we can't observe it. So we might, 50 years from now, have a theory, a unified theory, which explains the physical forces and perhaps also allows us to explain some of the 6 numbers I mentioned, which we now can't explain. And if it managed to do that, because it made predictions we could test in a low-energy world, then we would take seriously its prediction in the very early universe. So to that extent, I think we may actually be able to firm up whether a particular kind of multiverse is likely.
Well, that would be a fascinating discovery to make.
And it would be really an extra Copernican revolution, because we had the original Copernican revolution, and then we've had the realization that our solar system is not unique, and that our galaxy is not unique, and then we will realize that our Big Bang is not unique.
Right. And you did mention your PhD thesis actually helped refute the steady state theory of the universe, correct? We did not have certainty on this Big Bang thing.
That's right. And
yeah.
I think the reason I've been so fortunate, really, is that in the 1960s, all these new things happened.
Right.
Good evidence of the Big Bang, first evidence of black holes, neutron stars, etc. It was very exciting. And those of us who came in at that time were lucky, because it's always good to go into a subject where new things are happening, because then you don't have to try and bang your head against the topics that the old guys got stuck on. You can do
Right.
new things.
Right.
And I think that was good for our generation. But what's especially elating is that the most recent 5 years have been just as exciting.
Oh, yeah.
If you think of the new things that have happened there, exoplanets, gravitational waves, firmer evidence about the Big Bang, etc., it's just as exciting. Not that we are especially clever as individuals, but because we have new instruments which
Yes.
can probe, and also more powerful computers. Because the other thing which has changed very much in the last 30 years is the ability to do computer simulations which are realistic enough to allow you to actually do experiments in a virtual universe. You can ask what would happen if you crash two galaxies together or two black holes together, and then see if this compares well with what you actually observe. Until 20 or 30 years ago, computers weren't powerful enough to do these calculations, realistically. But now they are.
Well, may the next 5 years in astronomy and the 5 years after that and the 5 years after that be every bit as electrifying as the past 5. And thank you very, very kindly for inviting me into your lovely office here in beautiful Cambridge.
Well, it's great to meet you. We could have gone on for many hours, I think, discussing all these.
Oh, I'll probably drop in again and hit you up for many, many more hours at some point.
Yes, okay.
Thank you so much.
And thank you, Rob.
It's hard to convey what an honor and delight it was for me to interview Martin Rees. As some of you may know from earlier episodes of this show and or my special bonus Patreon recordings, his 2003 book about existential risk profoundly impacted my perspective on our relationship with our technological creations. That impact hasn't diminished one iota in the intervening 15 years, and his new book, On the Future, complements that first book beautifully. On the Future is already available in the UK, and it'll be released in the United States 2 weeks after the day this episode debuts, specifically on October 16th, 2018. I'll add that it was really special interviewing Martin in his Cambridge offices, which are every bit as elegant and classic as you might imagine, with atmospheric touches like that lovely clock that gonged every so often during our conversation. If you enjoyed this episode, I again strongly urge you to check out the first of the 4 weekly installments of my essay, Privatizing the Apocalypse, over at medium.com. A lot of the themes that Martin and I talked about are going to be present in that series, which will run over the month. You can find it at medium.com/@RobReed. And again, as I said at the start of the show, I'm afraid that complicating @ symbol is a mandatory part of the URL. So again, medium.com/@RobReed. And of course, Reed is spelled R-E-I-D. I'll also post a link to this article in the show notes to today's episode at my website, which is at after-on.com. Meanwhile, I have a really special treat for those people who support this program at a level of $5 a month or more at Patreon. Those supporters are currently this show's only source of economic support because I don't yet have ads. I'm not part of NPR or any podcasting network, so patrons, thank you again for making this possible. And today, to say thank you, I'm posting part of a fascinating interview that I quite recently conducted with the world-renowned roboticist Rodney Brooks, who is the father of the Roomba, among many other robots, a serial entrepreneur, the longtime head of MIT's AI and Robotics Lab, an extraordinary writer, and many other things. Rodney was also a guest on this show back in March, specifically episode 23. I interviewed Rodney and dozens of other people over the past couple months for a long and increasingly ambitious piece that I'm writing for the Sunday New York Times Magazine on the potential for science and technology to expand the range and sensitivity of human senses and to perhaps add entirely new senses to our palate. Rodney has published some fascinating thoughts about this on his wonderful blog, and today's special Patreon interview touches on this, as well as some other really cool subjects. It's just such a fun conversation. I decided to edit it down into a tight package and share it with my patrons, so please enjoy. I also hope that some of you who are not yet backing the show will consider doing so. I have created many, many hours of extra Patreon-only bonus content, all of which you'll get access to immediately upon joining if you support the show at a level of $5 a month or more. You don't have to support it at $5. You can support it at a lower level, although that doesn't unlock the content. And if you'd like to make a bigger statement of support or help the show a bit more, you can really pick any arbitrarily high figure. And I noticed that and appreciate it. In fact, 2 people support this show at $200 a month, which blows my mind and makes me very grateful. Anyway, I add to the archive of many hours of content every time I post a new episode, and sometimes I post extended versions of the interviews that go out on the main feed. So patrons might literally hear 50% more of a given conversation. I did that with Stuart Brand a few months ago, with Yale astrophysicist Priya Nadaranjan in the episode which immediately preceded this one, and I'll be doing more of this in the future, perhaps as soon as next time, actually. To join the party, just head on over to patreon.com/Rob Reed. Patreon is spelled Patreon/Rob Reed. Reed is R-E-I-D. If you're not financially able or just not inclined to back the show financially, you can still help it a lot by spreading the word about it. For each episode, I post a very self-contained tweet, which carefully describes the current show. And the Martin Rees tweet is already up in my feed at twitter.com/Rob_Reed. So please consider helping this show light up new neurons out there by forwarding these little synopses around. Most of my episodes are only retweeted a couple dozen times, actually. So I absolutely noticed and deeply appreciate all relevant activity on Twitter. The last and most simple, easy, time-efficient, and utterly free thing you can do to help this show expand its audience and therefore hopefully survive is to rate it on iTunes or on Apple's Podcasts app. Both of these apps, frankly, have rather squirrely user interfaces, but if you made it through today's episode, or frankly, any of my episodes, you are definitely smart enough to figure it out, I promise. These ratings matter to Apple's promotional algorithms and therefore really do help the show expand. That's it for now. I have 3 further installments of the Medium article, which premiered today, coming up in October. Again, that article, the main title is Privatizing the Apocalypse, coming up in October, and a fresh episode of the podcast in 2 weeks. I hope you'll join me.